Hello, my name is Michael Monaghan. I'm a professor here in Trinity College, Dublin. I'm also the director of the M.Sc programme in Biomedical Engineering here at Trinity College, Dublin. So what is biomedical engineering? Biomedical engineering can be defined as the application of engineering in medicine, physics, chemistry and mathematics to develop new devices and new approaches to improve healthcare and improve people's lives. Biomedical engineering at Trinity College Dublin is a well-established programme. We exist in the School of Engineering, which is the oldest school of engineering in Ireland and one of the oldest in the world. Trinity College Dublin is Ireland's premier university. It is ranked highest annually by the Times World University Rankings. Biomedical engineering is multidisciplinary. This is an approach that we adopt here in Trinity. We span with academics coming from the School of Engineering, the School of Medicine, the School of Dental Science, the School of Natural Sciences, and we have many researchers from postdoctoral level, PhD level, and master's level. We perform world-class research in biomedical engineering and are internationally renowned in this field. We've received prestigious awards, we've licensed technologies, developed spin-off companies, and gathered in excess of €20 million of research funding in the past 5 years alone. Trinity Centre for Biomedical Engineering, to which we are closely aligned with this M.Sc programme, has close links with all 5 teaching hospitals in Dublin. These include St James's Hospital, Tala Hospital, St Vincent's Hospital, Mater Hospital, and Beaumont Hospital. We look to apply learning and course material to real-life situations, real life that occurs in the clinic or occurs to our public, through who we reach out to and engage with yearly. Our programme aims are first of all to develop a broad understanding of the key subjects of biomedical engineering. These include biomechanics, biomaterials, bioinstrumentation, neural engineering, rehabilitation engineering. But at the same time, with these broad understanding of these key subjects, get familiarity with the main surgical disciplines, including orthopedics, cardiology, gastroenterology, ENT surgery, and neurology. We imbibe our students with a solid understanding of how to apply scientific methods that are tested, that are proven, that are accurate, that are ethically correct to research in an industrial or clinical context. The ability to exploit information technology to monitor the performance of medical devices or health of patients is one of our key emerging technologies. Knowledge of how the medical device industry is regulated and of how to obtain acceptance of new products onto the market is a strong foundation which we equip our students with. Being a biomedical engineer right now, today in this world, is a very attractive career path. Employability is very high. There is a huge demand for biomedical engineers. 50% of the top 25 medical device companies worldwide are located in Ireland. Ireland has an exceptionally strong biomedical engineering employment base. Since the initial development of the medical device sector here, over 40 years ago, the success has exceeded expectations, trebling in scale in the last 15 years. International companies recognise that we produce high-quality graduates here in Ireland in biomedical engineering and highly skilled individuals. Overall, medical technology companies in Ireland employ approximately 25,000 people. The market is huge and it's increasing constantly. Successful graduates of our M.Sc programme move on into a diverse array of different paths. This can include further research or academic routes through PhD programs, both nationally, locally, and also internationally in the USA and in Europe. Some have moved on into study medicine and others to move into industry, which, as I mentioned, is exceptionally strong in Ireland. Our programme structure is very well defined, and we have 3 streams. The first stream is our M.Sc in biomedical engineering, and it's a general stream. We have an M.Sc in Biomedical Engineering with a specialisation in tissue engineering, and an M.Sc in Biomedical Engineering with specialisation in medical device design. We have a wide range of modules. These modules can be 5 ECTS or 10 ECTS typically. And they are tailored to maximise the potential, learning and development of our biomedical engineers taking our M.Sc programme. Some of the modules are shared among all 3, some are optional, and some are very, very specific to the specialisation upon which the student picks. Typically, the specialisation is discussed in depth with potential students to maximise their previous experience and build on that. One of the main components of our M.Sc programme in Biomedical Engineering is an in-depth 11-month research project. This is one of the greatest strengths of our programme. Typically, the assessment or weighting of our research project accounts for almost 50% of the total credit of the M.Sc programme. The research project begins on day 1 and students are continuously working on their project. They work on their project under the tutelage of a personal investigator or a professor who describes their own research interests, and the student then works on a project related to their research. They become part of a bigger team, which consists of other PhD students, of postdoctoral researchers, senior researchers, and exposure to other researchers from other groups that share lab facilities. More information on our research can be found on our website. Much of our research takes place in the Trinity Centre for Biomedical Engineering, and this centre integrates biomedical engineering research across 4 disciplines and 3 faculties of Trinity College, but also across other institutes, including the Royal College of Surgeons in Ireland, University College Dublin and Dublin City University. This here is the building where the majority of the research takes place in Trinity Centre for Bioengineering, that consists roughly of 24 personal investigators, postdoctoral fellows and PhD researchers. Our research teams are very diverse but very exciting, with significant advancements made in recent years in tissue engineering, regenerative medicine, neural engineering, biomechanics and mechanobiology, medical devices and advanced drug delivery. More information on our research can be found on our website and looking up our individual profiles. We partner a lot with local academic institutes and also large research centres that are present both within our institute and in other institutes, with clinicians from the various teaching hospitals, with companies, large multinational companies, small spin-off companies, and also with the larger centres present in our hospitals. Here is an additional list of international partners that we have throughout the world, both in Europe, USA, Australia, and so on. I do encourage you to look up our individual principal investigators that are present in our centre, who will often prescribe different projects that can be conducted in our M.Sc and Biomedical Engineering programme. This is just a quick example of thesis projects, and you can see that they've been divided up into their specialisation, be it a general stream, a tissue engineering specialisation, or the medical device specialisation. And these projects have been intimately tuned and created to address the learning outcomes of the different specialisations. Our students have a very diverse year, a very active year here in Trinity College Dublin, and engage on many, many activities that are extracurricular but are very conducive to their development as biomedical engineers. Here, for example, is where our students have been at local and national conferences to present posters or oral presentations, and in many cases have won awards based on their research projects that they presented through this oral and poster format. Our students engage a lot with our community through our different modules that we have designed. One particular module is our Innovation Design module that has the initiative Med3DP imbibed in it. Through this initiative, students visit schools, they take part in different fairs, engagement fairs, both locally and nationally, and talk to the public about the 3D printing of medical devices that they're engaging upon. This gathers quite often media attention, and on the next slide we have an interview from one of our students that was invited from a local newspaper.
My name is Pooja Mandal and I am from Trinity College, Dublin. I'm doing my Masters in Bioengineering over there, and a part of my Masters involves a module named Design and Innovation, where we are making medical devices for disaster zones. We have designed a site called the Med3DP in which we are all clubbing our heads together with different kinds of really basic and conceptual designs, where people all around the world, wherever the disaster zones are, they can, if they have a 3D printer, they can just like pull out those designs from our website and they can just have those medical devices right there. Today we have been showing 3D printing. Basically, many children were not even familiar with the concept of 3D printing, so they were really excited to see something working over there. We tried to explain them that we are doing medical devices over there, and they didn't much understand that, but they were pretty happy with it. The most common question all children asked was, how is the printer understanding what we are telling it to make? So we explained them just like how we speak English, the printer speaks a language called the G code, and they were very excited. They all were like, we'll go home and we'll YouTube those videos and we'll see how it's going to be made.
So those are going to inspire the next generation of 3D printers and makers and things.
I hope so, but we did because we are inspired so much. Like we did tell them that they can use it for anything. Like many of them were into the the concept of computer designing, and they were all into the designing stuff, and we were like, you should go for it.
So that's an example there of one of our previous graduates providing an interview to local media based on one of the activities that we have running through our M.Sc program. And just to add on this Med3DP initiative involves a lot of diverse skills. So the students use our maker spaces in our engineering building to do a lot of 3D printing and design. There's some website design as well, and there's a lot of engagement with both clinicians, charity outreach people, and first aid activists. Another activity that we have that is extracurricular but is very important to the development of our students is our research seminar series. We're very fortunate to have a very strong research base in biomedical engineering here on Dublin, with many of the local institutes also having very active groups in biomedical engineering. And because of this, between the different institutes, we have a lot of international speakers visiting Dublin. This gives us the opportunity to invite those speakers to give a talk and also to engage with them. And they are very often excited to speak to our M.Sc students and discuss research with them. The welfare of our students is very important to us. We typically have small class sizes for our M.Sc program and a maximum 20 students. We do this because we want to ensure that we have a high quality group and cohort to work together with each other and keep that standard up. We also want to ensure that we can deal with students on an individual basis and listen to students' welfare and their views on our program. So it provides a means by which students, through our staff student committee, can relay their views to us. And we meet often with our students. We get to know our students on an individual basis. So that's all the information I have today, just in this presentation, but you'll find more information on our website down below, and you'll also find at that website email address through which you can address any further questions. I look forward to speaking to some of you through when you send in your application. Many of you will be invited for an interview and you'll get to meet me personally. So thank you very much for your attention and for engaging with me today.